You might think a spacecraft just points at a planet and flies straight toward it. But that's not how space travel works. Every planet is moving. Earth is moving. The sun's gravity is pulling on everything. To reach another world, a spacecraft must follow a carefully calculated curved path called an orbit transfer. Sometimes, it even flies past other planets first, using their gravity like a slingshot to gain speed while saving fuel. This is how missions designed by NASA can travel billions of kilometers with limited fuel. The result is surprising. Spacecraft don't take the shortest path. They take the smartest path. Mercury is the closest planet to the Sun, and you might think that makes it easy to reach. In reality, it's one of the hardest destinations in the solar system. A spacecraft leaving Earth is already moving very fast around the Sun. To reach Mercury, it must slow down against the Sun's gravity, which requires enormous energy. That's why the Messenger mission took about 6.5 years to arrive. It had to loop around planets multiple times, using gravity assists just to reduce its speed enough to be captured by Mercury. Venus is much easier to reach than Mercury. When Earth and Venus align correctly, a spacecraft can arrive in just 4 to 5 months. Because Venus orbits closer to the Sun, missions often use it for gravity assists to change speed and direction. Many interplanetary probes swing past Venus before heading deeper into the solar system. In space travel, Venus is not just a destination. It's a powerful stepping stone. Mars is often called our neighboring planet. But even at its closest, it still takes 7 to 9 months to get there. Spacecraft must wait for the perfect launch window, when Earth and Mars are aligned just right. Miss that window, and the journey becomes much longer and more fuel-intensive. That's why missions like Perseverance carefully time their departures years in advance. Mars may be close in space terms, but reaching it still requires patience and precision. Beyond Mars lies the realm of the giant planets. Reaching Jupiter is a major step into deep space. Even with powerful rockets and gravity assists, the journey takes around 5 years. The mission Juno followed a long, looping path before finally entering orbit around Jupiter. At this distance, sunlight is weaker, communication delays grow longer, and every maneuver must be planned far in advance. Jupiter marks the point where missions stop being short trips and start becoming long expeditions. Past Jupiter, the distances grow enormous. Reaching Saturn typically takes 6 to 7 years of travel. The mission Cassini, Huygens launched in 1997 and arrived at Saturn in 2004 after a complex path using multiple gravity assists. By the time a spacecraft reaches Saturn, it has traveled billions of kilometers through deep space. This is where missions truly test the limits of engineering, patience, and long-term planning. Uranus lies so far from Earth that very few missions have ever gone there. The only spacecraft to visit was Voyager 2. It took about 9 years to reach Uranus after launch. At this distance, the Sun looks like just another bright star. Communication takes hours, and every command must be sent far in advance. Uranus is where the solar system begins to feel truly vast. Even farther lies Neptune, one of the most distant known planets in our solar system. The only spacecraft to ever reach it was Voyager 2, after a journey of about 12 years. By the time it arrived, Earth was already far behind in its orbit around the Sun, and the spacecraft itself had traveled billions of kilometers through deep, silent space. At Neptune's distance, the Sun is so faint it barely illuminates the planet's deep blue clouds. This is the frontier, where our solar system begins to fade into interstellar space. And then there is Pluto, once called the 9th planet, now a distant dwarf world at the edge of our solar system. The mission New Horizons took about 9.5 years to reach it after launch. During that time, the spacecraft traveled farther than almost any mission before it, crossing billions of kilometers of empty space. When it finally arrived, Pluto was not a bright, detailed world from afar, but a small, icy planet-like object in deep darkness. A reminder of just how vast the distance truly is between worlds. When you look at all these journeys together, one truth becomes clear. Reaching other planets is not about speed, it's about time. Months for Venus, years for Mars, Jupiter, and Saturn. Nearly a decade or more for Uranus, Neptune, and Pluto. Every mission sent by NASA is a carefully planned journey across moving worlds, timed with precision that spans generations. In space, nothing is instant. Nothing is simple. Even the closest planets demand patience. The farthest ones demand decades of planning, engineering, and waiting. And in the end, space travel is not just a journey through distance. It is a journey through time itself.